So hi everyone. So in today session we are going to talk about two very important concepts in the database and system design, that is ACID and BaSE. So these two models going to define your system, how your system going to handle the backend part, backend in the sense the database part. So data consistency problem or reliability, performance or scalability. So these four concept is going to be impacted by these two concept. Okay, so if you're preparing for the interviews or working with the microservices or designing some scalable system, this topic is going to be very extremely important for you. Okay, so let's start with that. ACID first. So most of you must have heard about this. So ACID is primarily used in the relational database. So when I say relational database, means like MySQL, where your data can be structurally defined. Okay, Postgres and Oracle, most of the database which are famous, you might be knowing that. Okay, SQL Server. Okay, all these are relational database, and ACID property ensure a strong consistency and reliable transactions. Okay, so it is give you assurance like whatever we are doing, your transaction is going to be consistent. Okay, consistent and reliable. Correct. So let's it's an acronym, so let's expand this now. So A stand for atomicity. Okay, so atomicity means, as the name suggests, either complete it or do nothing. So it's all about all or nothing. Correct. So what does it mean? So it means that a transaction is treated as a single unit. When any transaction is started, it has to be finished. It cannot hold on between, it cannot stop in between. So we started here, it has to reach the end. If anything happen in between and it's not reaching the end, then we consider this transaction as a failed transaction. Okay, so there is nothing like partial transaction or nothing. No, either everything happen or nothing happen. So no partial execution is allowed. So for example, if I say you, suppose you are transferring some amount from one account to some another account of your friend. So what happens? First money get deducted from your account and immediately get credited to your friend account. If the system crashes after step 1, I mean step 1 is suppose debit of 5,000. Okay, and second step is credit of 5,000. Okay, fine. So if this step happens and somehow your system got crashed, so step 2 will never happen, right? So atomicity ensure that transaction is rolled back and money should not be lost. Okay, so this is one case. Either both succeeded, then also we consider this transaction succeeded, otherwise it's going to be failed. So this is the meaning of atomicity, and it is very critical property, especially in the banking system. It's very much useful, and we emphasize on this kind of concept when we are going to do some very critical transaction. Okay, now coming to C, acronym C. C stand for consistency. Okay, so consistency means at any point of time your states are always valid. Okay, what does it mean? So consistency ensure that database always follow the rules and constraints. So before and after any transaction, data must remain in valid state. Let's say one example, suppose your bank cannot go below 0. Okay, I mean there is a minimum amount that should be maintained in an account, and that is suppose 0. So or 10, any amount you can take. So if you try to transfer 10,000 but only have 5,000, okay, and you are going to transfer 10,000, then what will happen? The transaction will fail, because database is saying saying if you are going to transfer 10,000, your account status will be in minus, and minus is Validation is that account amount cannot be below 0, so it is an invalid state. So database prevent invalid state, so rules are always enforced and no corrupted data. Hope this makes sense, right? Now consider the third one, that is I. I stands for isolation. It's a very important, a little confusing property, so just understand. It says no interference between the transaction. If two transactions are happening, there is no point that it should impact each other. So isolation ensures that multiple transactions does not affect each other. Even when many users are working on the same time, each transaction behave as it is running alone. Okay, so let's say one hotel booking site is there, right? And two users trying to book the last hotel room at the same time. So there are multiple rooms, everything is booked. Okay, this is backend, and user 1 and user 2 is coming. So user 1 initiated support transaction 1, transaction A or 1. So it reads room availability 1, means room is available. Transaction B also comes and it also see, okay, room 1 is available. So without isolation, both may book. Remember, if both are looking, this room is available, this room is available, so both can book the room, and this is invalid transaction, right? So without isolation, both may book and overbooking happens. So with isolation, what happen? Only one transaction succeed, other will fail or retries. So while booking, we are going to enforce some rule. Before making the payment or before confirming, just check this room is still available or not, right? So this is a function of isolation. So isolation always prevent double booking or overbooking in this case. So remember, isolation always ensure that multiple transactions should not affect each other. Okay, now coming to D. D stands for durability. Okay, so durability is nothing but it's a kind of permanent storage. Okay, it says whenever transaction is complete. When I say complete in database term, you should say when your transaction is committed. When transaction is committed, it is permanently stored. Okay, even if system crashes, power failure occurs, anything happen, if committed is called, then it should be stored in the table, or permanently it should be stored somewhere. So suppose you successfully transfer money from one account to another account, and you got the message and confirmation, yeah, money is transferred. It means that transaction is complete now. So even if the server crashes or something happened, but when the server will log up, you must see the transaction in a complete state. Okay, so your data or your money is not going to be lost. So my point is that whenever any transaction is getting committed or completed, durability guaranteed that it is permanently stored and it should not be lost in any case. Okay, so this is all about ACID. So ACID focus on what? Strong consistency, first thing, right? Data accuracy, because there is no invalid state, and third is reliability. Even though system is crashing, your data which is completed, it is stored, right? So like I told, ACID mostly used in banking system. First thing is very important with there. Any kind of financial transaction, because where consistency is very important, right? Or order processing system. Okay, so these are the case where ACID fits. Okay, now coming to BaSE. So what is BaSE? Actually, BaSE stand for basically available. and S stands for, it's a BA actually, so S stands for soft state, correct, and E stand for eventual consistency, just opposite to strong consistency. Okay, so let's understand this. So whenever you are doing some distributed kind of system you are building, or you are going to use NoSQL database or something cloud scale application, in that case BaSE is mostly used. So BaSE focus on what? High availability, first thing. Okay, scalability and performance, right? So let's understand this acronyms now. What is this? BA, basically available. So what is this? So basically available means the system always respond to the request, first thing, even if some nodes get failed or some data is outdated. For example, in Amazon and Flipkart, even if some server is down, you can still browse the product and system remains available. Okay, so it says in a very basic term, your system, whether partially down or down, whatever it is, customers should not be impacted, so your system should always be available. Okay, so like e-commerce application, okay, then mostly they always up, right? Now coming to S. So S stand for soft state, right? So what does it mean? So data can temporarily be inconsistent, means if some transaction is happening at this place, there is another application who is consuming this state change, so might be take some few millisecond or 1 second or 2 second kind of delay. So for this particular 2 second, here suppose transaction, my name is suppose Ravi get converted to Mr. Ravi, I change my name. Okay, so might be in this system, this may available this new name after 1 second. So for that 1 second, this data can be temporarily inconsistent. So it may change over the time even without a new input. So because updates propagates across nodes synchronously. So once the change is happening, so there are multiple queues, there are multiple ways, some distributed platform. So they are consuming this, they are propagating this, they are processing it, then they are going to update this. Okay, so like in suppose in a distributed system, what happens? Suppose node A update data, just like suppose it's a node A and this is node B, correct? So node A update data, so but node B still have some old data for 1 second, right? So for some time different nodes show different values, eventually they sync, but ultimate goal is that they are going to be same. Okay, now coming to next letter, that is E. E stand for eventually. Sorry, I think we missed. No, S we done, right? And E, event, right? Okay, event consistency. So let's talk about event consistency now. So eventual consistency means data will become consistent after some time. Eventual, like strong, when I talking about the strong, it means immediately it was happening, and this is not immediately but will happen. Okay, it's going to be inconsistent but not immediately. For example, suppose in Instagram or Facebook, when you see any post, when you like this, what will happen? Maybe for me, suppose you liked my photo, and if I sing looking at the same photo at the same time, might be earlier my likes were 5, when you click it should be 6, might be you are able to see 6, but here I am able to see 5 for some time. Okay, so this updated count the user can see immediately, but another user may still see the old count. So but after few seconds everyone see the same count. So this is the eventual consistency. All right, so this is all about the base. So if I summarize it, so BaSE focus on what? Availability. Whether partial system is down, anything is down, user should not be impacted. Speed, because when you liked it, it's immediately you are able to see, but other system will get those things after some time. And scalability. Okay, so mostly this is used in social media and like big data system or some distributed application. This is applicable. Okay, so if I compare this feature wise, I'm telling this because sometime in an interview people used to ask, and this, the things but you don't know the name, so that is also important sometime when you take this word BaSE and ACID, so it's give an impression that the guy knows the things, right? Okay, so I've written down some property. We already discussed that. Consistency. So consistency is strong in which case? ACID, right? Here is not, it's eventual. Let me write here, not cross. It's eventual, correct? And here it is strong. Now coming to availability. So availability is always very high in the BaSE case, right? It is lower. Data accuracy, of course ACID is having the more accurate data, right? So it's kind of better, or you can say immediate better. Okay, it's not the highest kind of accuracy, but it's better than in case of BaSE, and this is delayed. Now coming to performance. So performance is always faster in the case of BaSE because you don't have to update all the node in the same time. Okay, once the current node is done, it gets sync after some time, so you don't have to wait for that. So performance in this case it a little bit slower, and here it is faster, correct? Now coming to scalability. Of course scalability is very high in this case of BaSE because it support transactions in such a way that it's eventual consistent, so it's going to take less time and it's going to scale with the more system, and this is having the limited scalability, right? And of course the use case like where we can use this ACID used to we normally use in the banking system or any financial transaction. Okay, and BaSE case used in social media or some large app, right? So now most important part, like when to use which model, right? So as I told, so we should use when data must be 100% correct and no inconsistency allowed. It's a financial system or payment processing or inventory system, right? So ACID is best. In case of BaSE, when system need to scale massively, just like any social media platform, or high traffic application, just like social media you can take, or some big applications, real-time user experience matter, or slightly delay in the consistency is acceptable or allowed. So in those cases we should go for it. So ACID for correct data immediately, and BaSE fast system, data correct eventually. Okay, so that's also so what I say, we know that ACID gives you reliability and strict consistency, and BaSE gives you speed, availability, and scalability. So in the modern architecture system like microservices, both models are often used together depending on the use cases. Okay, so let's see you in the next one.